Hello my dear friends. Today in this video we are going to discuss about the first chapter of 12th grade, that is electric charges and field. Before we begin this chapter, little bit of introduction, a background about this chapter. So first, electric charge and fields are related to electricity. So in this chapter we have to learn about the electricity, but electricity also it's a general term. We divide electricity into two major divisions. Electricity is a branch of physics in which we have these two subdivisions like electrostatic and current electricity. Electrostatic, as the name suggests, static means a stable charge. So those physical phenomena which are related to stable charge, when charge is stable, it's not moving, suppose positive charge, it's not moving, then what will happen? What all physical quantities are possible? So like we have to discuss about the Coulomb force, which is electrostatic force. Then we have to learn about the electric field and potential. These are the three major topics, and one application, capacitor. Along with this, one application of capacitor we have to study. So these main topics will come under electrostatic. And then we have second topic, second subdivision, that is current electricity. This is related to the moving charge. When charge is moving, then what will happen? Like current will develop, electric current, we have to discuss about electric current. When current will develop, then it needs a circuit, then only it can flow. Then there will be some resistance. There are two types of current also, AC, DC. Then we have heating effect and magnetic effect of the current. Along with this, we have to study about the inductors also. There are some devices which we have to study. So all these topics comes under current electricity. So these two chapters are there. First chapter is fully based on the electrostatic, and second chapter we have current electricity. Second chapter actually is related to electrostatic itself. In physics, we have first chapter is related to charge and electric field and force. Second chapter we have related to potential and then capacitor, and all those things we'll discuss. So in this chapter, first we have to start with the charge. What is charge? Because everything, whatever is related to charge, that comes under electricity. And these two are the only possibility, either they are stable or they will start moving. Now we'll discuss a little bit more about the charge. So first we'll discuss what is charge, then we'll discuss in this video we'll discuss about the development of charge also, how can we develop charge on any object, and then properties of the charge. Like three major properties are there: additive property, conservative property, and quantization. So these three properties we will discuss. Now first, what is charge? Charge, as we know today, because all the matter, charge is just like mass. Mass is the fundamental property of matter. Same charge is also a fundamental property of matter, along with spin also. So charge, as we know today, there are two types of charges, positive and negative. We can give many examples for positive charge, like protons. We can start with the protons. Neutrons are neutral, protons are positive, electrons are negative. Then we have some ions like sodium ion, which is positive charge. Then we have aluminium, suppose aluminium 3 plus. Here oxygen O2 minus, like this, chlorine minus. Like this we have positive and negative charges. But recently we have discovered this electron, like electron and protons. First, because the concept of electron was given by J.J. Thomson in 1897. So recently we have discovered this, but the concept of charge and electricity is not new. It was known long back, like around 300 BC. Those things we'll discuss with the help of the NCERT book. We'll go to that book now. Like suppose in this chapter, the first introduction only, we have discussed about this, which all topics we have to discuss in this chapter. and then electric charge. They have started with one example like amber and wool or silk. If you rub them, then charge will develop. Then they'll start interacting with each other. And that was known to those people who were living 600 BC ago, like Thales the Miletus. So Thales knew about this. So there should be some charge. After rubbing, some physical phenomena will develop which will start attracting these two objects, attracting or attraction and repulsion will happen. So he has studied about some pairs of the materials. So those pairs, now we have one table. In that table, we can discuss about those pairs. Like suppose here we have this table. So in this table, this is called triboelectric series. Just like in chemistry, we have studied about series like reactivity series. Same here, similar. So here glass, we have started with glass. At the top there is glass, and at the bottom there is related to plastic, right? Teflon and PVC. So if you rub glass with the silk, some charge will develop on this and some charge will develop on this. So just opposite charge. So here glass will, if you rub glass with silk, then silk will become negatively charged because it is negative side, and this glass is at positive side. So that's why glass will develop positive charge if you rub them. So this is one pair. We can have many pair like that. We can have another, like suppose we can take one steel rod or even paper or copper or silver, anything, and you can rub this with any fur. Suppose you take fur and if you take a steel, then steel will become negatively charged and fur will become positively charged. Then you come to the last, the bottom one, plastic or PVC. If you rub this with anything like suppose fur or silk, then this will become positive charge and this will become negatively charged. So like this we have many pairs. You can make some pairs out of these examples. From these two objects, if you rub, charge will develop. So that was the first thing, like which was known to those people also 600 BC ago. So that was the first thing. That is how they developed the charge. So this charge, we know that there are two type of charges, positive and negative. But who gave this name positive and negative? Why positive and negative only? So the charge which was developed on the glass rod, that was considered as positive charge, and this considered means by convention we have taken this charge as positive, and this was done by Benjamin Franklin. And not that, because Benjamin Franklin, he gave this concept of positive and negative charge somewhere around 1700. So he gave this concept. Why? Because if you take +2 charge, +2, because we know that two different charges are there, positive and negative. And if you, why positive and negative? Because they behave like this. If you add +2 and -2, what will you get? 0. So they nullify the effect of each other. Same thing was happening there also. While development of charge, suppose you rub a glass rod with suppose silk, then glass rod positive charge will develop and here negative charge will develop. And if you put them together again, then what will happen? They will cancel the effect of each other. It means it will become 0 charge, neutral. So this was the reason why this is mathematical concept, because in mathematics also same plus and minus, if you combine, it will become 0. So it will nullify the effect. Same thing was happening with the charge. That's why Benjamin Franklin took this as positive and negative. And by convention, whatever charge was developed on the glass rod, that was considered as positive. And the charge which was developed on the plastic rod, that was considered as negative. If you rub glass with the silk or this one plastic with the fur, then fur will become positively charged and this plastic will become negatively charged. So that pair which we have learned just now, that is triboelectric series. So with the help of that, we know that there are some charges which will develop on opposite charges will develop if you rub them together. So these are the few examples. Now the first, because two different type of charges were developing and they were behaving differently. If you rub glass with the silk and then if you put two glass rod together, then they'll start repelling each other. And if you electrify this plastic rod and then this again another plastic rod, then again they will repel each other. And if glass rod and plastic rod, after electrifying them, if you put them together, then they'll start attracting each other. It means there should be two types. So first they decided that there should be two types with the help of this attraction and repulsion. Same charge will repel and opposite charge will attract. So there should be some different charge here on the plastic than this glass. That's why they are attracting, because if you put them together, similar charges, then they'll start repelling each other. So it means there should be two charges. First thing they decided like this with the help of attraction and repulsion. And then they named it, because by convention they took glass rod, charge on the glass rod they have taken as positive charge. So this was the naming of the charge, like how we have only positive and negative charge, how and why. Now second topic which we have is development of charge. So development of charge, there are three methods. Development of charge, we have three methods. First method, if you look at this, like we can develop charge with the help of friction. First thing, this topic will discuss, and this charge can be developed with the help of friction. First thing, friction, which just now we discussed, just by rubbing it, right? Friction or rubbing. So just by rubbing you can develop the charge. Second method, we have conduction, friction, conduction, and third method we have induction. So these are the three major methods with which we can develop the charge. Friction just now we discussed, with the help of those triboelectric series we can decide which on which object which type of charge will develop. Then second method is conduction. Conduction means if one object is already charged, then another object will also get charged. How? If you touch them. So like suppose we have one one ball like this, it is positively charged. Another same suppose metallic ball which is neutral, like there is no charge on this, zero charge. Now if you touch them or if you combine them with the any conductor, then what will happen? Charge will transfer from here to here. Some positive charge will develop here also, and here some so here some because of the negative charge, and here some positive charge will develop. So this transfer of charge is possible, and this is only possible when you touch them, when you combine them with some metal or something conductors. So this method is known as conductor. So with the help of conduction also we can develop, but for that we need at least one charged object. And friction, we don't need any charged object. First you rub them, the two opposite charges will develop. So in conduction we have like one already charged object. With the help of that we can develop another charged object. Second method we have in conduction, and third method we had induction. Induction means without touching, like without touching we can develop the charge. So this thing we have to discuss here. There are two methods which charging by induction we have to discuss in this chapter. Few topics are left here that will come later, but since we are discussing about the charging by induction, charging, like how can we charge the object. So first we discuss about friction, second we discuss about conduction, and now we have to discuss about induction. So induction means without touching you are developing the charge. So one method is given here in this picture, you can see. In the steps we can understand this. First, like you take two charge metallic this any two ball, which can be pith ball or it can be anything like plastic or any ball. Then what will happen if you charge one rod here, this rod. Suppose these are two neutral balls. It can be anything, just like we discussed. We can have pith ball or we can have any metallic ball also, no problem. Then we will take one charged rod here, and if you bring this charge rod near to this ball, then what will happen? All the negative charge will develop at this side and positive charge will develop this side. Because why? Because we discussed opposite charge attract each other. So here because everything is made up of electrons and protons, right? Everything. So that's why here negative charge are free, so they'll shift this side. And since charge is conserved, those things we'll also discuss because these things, all topics are mixed up, so that's why we cannot separate them entirely. So here at least we know all those things are very common. So here we know that everything is made up of electrons and protons. So here electron will shift this side, like those free electrons, and because of the conservation of charge, here positive charge will develop. Now what we do, now just you separate these two balls, then what will happen, and then you can remove this charged rod also. In that case, if you remove this, then what will happen, if you separate them entirely, then negative charge will develop on A and positive charge will develop on B. So we have developed charge with the help of induction. We have not touched this rod with any these two balls, but we are able to develop the charge on these two balls. So this is one method by which we can induce the charge on any object. Just like here, with the help of electric force, we have induced these two charges, positive and negative. So this is called charging by induction. There is another method also. Another activity is given in this book. In example, they have given. Suppose we don't have two balls here. We have only one ball. Same again, you charge one rod and you bring it near to this ball. Then what will happen? Since it is negatively charged, so positive charge will come to this side, and negative charge will develop in this part of the ball. Then what we do? You ground this. Part of this ball. Then what will happen? All the negative charge which has developed on this part, that will go into the ground. So in first step, we have to bring the charged rod near to this ball. Then what will happen? Positive charge will develop here and negative charge will develop this side, right hand side. Then this, if you ground them, ground is always at zero potential, means it will absorb all the extra charge which are there on the object. So here suppose some extra negative charge are there. This positive charge will, because it will stick to this negative charge because of the attraction between these two charges. So negative charge will flow to the ground. Ground is always at zero potential. That we will also understand later on when we will discuss about the potential in next chapter. Now here this, if you ground it, then what will happen? And if you remove, even if you at the last step, if you remove this rod, then here this ball is positively charged. This is how we can develop the charge by induction. This is another method, another activity which you can do. So here also this method can be considered as induction. So these are the three methods: induction, conduction, and friction, which we discussed first time. So these are the three methods. Apart from this, we have to discuss little about the conductors and insulator also. And one more things which we have to discuss, that is how to detect the charge, whether the object is charged. So now we know that we can develop the charge on any object. Now how will you decide whether the object is electrified or not? For that we need a equipment, we need a device. So here we have one apparatus which is called gold leaf electroscope. Now suppose one object is charged. With the help of this electroscope, we can decide whether the charge is developed on that object or not. So this is a very simple device, simple apparatus. In this apparatus, if you look at this, we have few things like here, this is the metallic rod, this part, metallic rod, and this is metallic knob. And here we have gold leaf. Why gold leaves? Because gold is most malleable substance. So we can make gold into very thin sheet. That's why we have taken gold leaves. We can take aluminum foil also, or any silver leaves also, no problem. So it should be metal. Now you, just because we have, these are very light, these leaves are very light, so we have to protect it from wind also. From outside there should not be air should not disturb this. So that's why we have put this gold leaves inside the glass, so that it is protected from outside environment. And here it is rubber, so that it is insulated. Now if you have something which is charged, if you touch this knob with that charged object, then what will happen? Charge will transfer, because it is metal. Charge will transfer, and these two leaves will get charged. So this positive, suppose it is positively charged, this will also get positively charged, and here positive and positive. Because of that, it will diverge, it will expand, because of the repulsion. We know that same charge always repel each other. So on this, suppose this side is also positive charge, this side also, so it will diverge, so it will expand. So this will prove, and same thing will happen if you put something negatively charged object, and if you touch this knob also with the help of negatively charged rod or anything, then again it will expand. So in both case, if it is expanding, and the degree of diversion will decide how much is the charge. Like if it is very intense charge is on this object, then what will happen? It will diverge more. If there is very little charge on this object, then little expansion will happen, diversion will happen. So, and this is electroscope, which you can find in your physics lab also. You can make it also once. It's very simple to make. So suppose you have you can have one aluminum foil in your house. So if you find that aluminum foil with the help of that, and if you have one rod, any metallic rod, and here one cork you put, and inside the bottle you put this, and you attach these leaves with this metallic rod, and if you touch, same thing will happen. Or whatever we are doing here, this is little professional. Here we can like make this systematic electroscope also in home also. It's very normal, we can easily make it. So but principle is same. If you touch something here, it will diverge. If something which is charged, it will diverge. If it is not charged, then nothing will happen. It will remain as it is. But if it is charged, then it will diverge. So this is about simple method. This is how we detect. First, we learn about how to develop the charge. Second, we have to detect whether whether object is charged or not. So with the help of this electroscope, we can decide, we can we can confirm that the object is charged. Now after that, we have to discuss about conductor and insulator. Those objects which will allow the current to pass through it is known as conductors, and those objects which will not allow the current to pass through it, those are considered as insulators. So generally conductors are like there are free electrons. Like suppose you take any metal. Metals are very good conductors. Why? Because there are free electrons which can carry the electron from one place to another place, which can carry the current from one place to another place. So here electrons are free to move in case of metals. So metals are good conductors. Best metal is electric conductor is silver. And there are many objects which are insulator, like plastic. We can have paper, we can have wood, like dry wood. So those are some example of insulators. So these are the two objects. Now if you remember this table here, why we are to electrify an object, we always take generally we can take metals also, but generally we take insulators. Look, generally in example we have taken here, like suppose plastic rod and cat's fur, these are insulators. Pith ball, these are also insulators. So if you rub them, and here glass rod and wool, so these are some example where all these are insulators. Why we are taking insulator? That should be one question. So the answer for that is we can develop the charge on metals also, but because in metals also there are free electrons which you can remove just by rubbing it. But why we are not taking metals? Because metals are good conductors. Even if charge will develop, suppose we take one metal stick, and if you charge it, it will become charged, suppose positive or negative. Now what will happen if this charge will not stay at this position, it will move, because this is conductor. Charge will not stay at a single point. So this will start moving, and if you touch it, it will pass through you also, and it will go to the ground. We are also good conductors. So that's why we are not taking metals. We are taking insulators. We are taking like plastic or silk, plastic, glass. These are insulators. So they are good insulators. So if you develop the charge on any insulator, then that charge will stay there. Like suppose here glass rod, and if you rub this with silk, then this part will become charged, and this will stay there because this is not conductor. It will not transfer to another part of the glass. So that's why here we can detect also. So it is convenient. Otherwise we can develop the charge on metals also. With the help of that triboelectric series, we can decide all metals are also there. Copper is there, aluminum is there, everything is there. So that is the one reason. Now insulator and conductors we discuss, and even in at home we use copper wires because copper is better than aluminum. So these are silver is the best conductor, then copper, and then aluminum. So these few you can see in your household. You can easily get these wires. So, and then we discuss about the charging by inductions. So this is the second part. Now third part which we discussed, we have to discuss about the properties of the charge. So there are three properties, basic properties. First we discussed, which was very common, like opposite charge always attract each other. Like interaction we can discuss, interaction of the charge that we discuss. Interaction like opposite charge always attract each other, and similar charge always repel each other. That is one property. Second, we have additive property. Additive property means suppose you have 5 coulomb plus charge, then you have 10 coulomb plus charge, and then you have 7 coulomb minus charge. And if you combine all these charges, then what will be the total charge? So we can algebraically combine all these charges. So here 10 plus 5, 15, 15 minus 7. So 8 coulomb will be the resultant charge if you combine all these three charges. So this is called additive property, means we can add charges algebraically. So this part of this nature, this property of this charge is known as additive property. Then second property we have conservative property. Conservative means just like conservation of energy, charge is also conserved. Charge of an isolated system is always conserved. Like suppose here we have taken two systems. Just now we discussed about glass rod and silk cloth. If charge will develop, means suppose here positive charge will develop, then here negative charge will also develop. So total charge, if you combine them, initially these two were neutral. Now if you combine them again, then if you touch them again, then what will happen? Again it will become neutral. It means if positive charge will develop here, negative charge will also develop here. So this is called conservation of charge, means total charge will remain 0. Initially it was 0. After transfer of the electron, this became negatively charged, this became positively charged. So because of the transfer of charges, but total charge was same. Charge we cannot charge can neither cannot be created and cannot be destroyed also. So in some situation, like suppose in neutron can be positron and electron, that we in nuclear physics we can understand. So we can develop, but total charge will remain same, just like in case of friction. development of charge we discussed. So total charge will remain same. So there are many examples where we can develop charge, but total charge will remain same. This property is known as conservation of charge. Now last property is quantization. Quantization means all the charge, any charge is integral multiple. Any charge can be written in the form of Ne, where E is the charge on electron. So minimum possible charge is charge which is there on the electron. So electronic charge, if you consider, because we had discussed there are two type of charge, a positive and negative. Electron is negatively charged. So this is minus, the charge on electron is 1.6 into 10 to the power minus 19 coulomb. This is very a small charge. So the charge on electron is this much. And same proton, if you consider proton positive charge, then this is also similar, little bit difference is there, but these are similar, but this is positive charge, 1.6 into 10 to the power minus 19 coulomb. So these are similar charge. So these are, so that's why any charge, whether it is positive or negative, can be written in the form of integral multiple of charge. This is called quantization. So we cannot have half of electron, no. Although there is, theoretically it is possible, like some quark, concept of quark, there we can have the charge in fraction also, but theoretically it is possible, but practically we have only integral multiple of charge. Means we can have 2 of electron, we can have 2 of protons or 20 of protons, but we cannot have half of electrons, we cannot have 1/5 of 1/5 of protons. So these charges are not possible. So this property is known as quantization of charge. Means all the charges are integral multiple of the charge on electron or proton. So this property is known as quantization of charge. So additive property, conservative property, and then quantization. These are the three major properties of the charges. Okay, so and this quantization of charge was first discovered by Faraday, Michael Faraday, and later on it was demonstrated by Millikan, Wilder experiment. And here Faraday was experimentalist. He was not a theoretical physicist, because he did so many inventions. He was doing some experiment related to electrolysis, and then he discovered that charges are quantized. So now 1 coulomb, suppose unit of charge, suppose charge we discuss, now unit of charge, SI unit of charge is 1 coulomb, but this 1 coulomb charge is not a small charge. 1 coulomb charge, if you find number of electrons which are there in 1 coulomb, it's many, because if you look at this, we have, if you take the simple mathematics, if you take 1 microcoulomb also, so it will have 10 to the power 13 electrons. Suppose you have 1 microcoulomb of negative charge, then this is equivalent to 10 to the power 13 electrons. So it's very, why? Because suppose just now we discussed 1 coulomb charge means 1 electron charge is 1.6 into 10 to the power minus 19 coulomb. So 1 coulomb will be 1 by how many electrons? 1 by 1.6 into 10 to the power 19 minus 19. So this will become 10 by 16 into 10 to the power 19. So somewhere around 10 to the power 18 electrons. So like this we can decide 1 coulomb will have, 1 coulomb of charge will have almost, if it is negative, then almost 10 to the power 18 electrons, which is very big number. And later on when we'll discuss about the coulomb, like coulomb force, then the force between two charge, 1 coulomb charge is not a small charge. It's very 10 to the power 9 Newton force will develop. If you place two charges, like here positive charge, 1 coulomb positive charge here, another coulomb 1 coulomb positive charge here, and distance between them is 1 meter, then how much force it will feel? It will feel 10 to the power 9 newtons, which is very big. So that's why 1 coulomb charge is big if you consider the electrostatic. So that's why generally we deal with microcoulomb, nanocoulomb also, okay. And quantization of charge is valid at micro level. Suppose you have some 1000 electrons, maximum 1 lakh electron, like that. If you can count those electrons, because the number of electrons is very large. So normally charge at micro level, at micro level this quantization of charge is not at all. We cannot consider quantization of charge. It's valid, but at macro level we'll just ignore that quantization of charge. But at micro level we have to consider when we can count the charges. So this is all about the charge which is there in this 12th grade. There are so many things to discuss, but we'll stick to the syllabus which is related to the CBSE pattern and NCERT book. And this I hope this video will be useful for you. So thank you for watching. Goodbye.